Well, hi, good morning, and welcome to my shop. My cat's about to go off a diving board here without knowing it. Today, I think you can probably guess from seeing the tube tester up on my bench and also the other tube tester down here, I'm going to be testing the tubes in the radio. And I expect it to go straight forward, except I don't, because I already know one of the tubes doesn't match the schematic. A different tube in one of the sockets. So got my notepad ready. So this tube tester is a emissions tester, a high quality emissions tester, a fairly well known one. This is a Jackson 648, and this tester is a mutual conductance tester or transconductance tester, whatever you want to call it. And so it tests tubes in a little bit of a different fashion. This is considered a technically more correct way of doing it, more accurate way of doing it, if you like. But I think from a practical point of view, just about any tube tester is going to find a bad tube. And splitting the hairs, I think splitting the hairs on tubes was more about selling them and convincing your customers that the tube is bad. And I think that's part of why a lot of tube testers have a big bad good area. You can show the client, look, bad. And when you went to show the client and you said, well, you know, the transconductance is supposed to be 5400, this one's testing at 3800, I think we should replace it. Bad. Good. You can see how different that is in a selling situation. But and why are you here today? Because we're having another ridiculously warm day today. The temperature's going to get up to 20, which is almost a summer-like temperature, when in fact it shouldn't be getting much above 5 degrees. It should be quite cold out. Even colder than that would be normal. So let's just turn this back. I see I left it up on 25. That's not good. Try to not leave your tube testers on real high filament voltages, or you're going to get a surprise, an accidental surprise. Well, let's get going here. Yeah, so I'm going to record the readings from both testers and have a chart for comparison when I'm done. Isn't that right? And I'm not sure I'm going to video the whole thing because it's going to be a bit of a long process here. Maybe I'll just kind of video the meter going up. That'll be challenging enough. What do you say? Is that a good idea? And we're going to start right out here. Throwing the first tube to the floor. 6H6, yeah. So I think this is a dual diode. This little short guy here. 6H6. Maybe I'll just record the first one in its entirety here. Right by it. 6H6. There it is. Good. Okay, 6H6. 6.3 volts. 1, 2, and 5. 4. 18. This is such an easy tube tester to use. That's another attraction of this guy. He's real easy. Did I not plug it in? Let's turn the power on here. There we go. So the meter's jumped up to indicate the line voltage. And that looks okay. Yeah. What do you think, Shadow? Shadow, what if I throw a little piece of paper right in here? Just giving a moment for the tube to warm up. There she goes. Oh, that should keep her occupied. Okay, so we're going to do the short test. Keep your eye on the little neon bulb here. Flashing is fine. Don't watch the cat now. Pass the short test, 6H6. I gotta hold on to the tube tester. And the test is two tests, XZ. XZ. There we go. Good. Next test, we change the 4 to a 6. Oh, and we change this up here. 1, 2, 3. I almost missed that. 1, 2, 3. Okay, 1, 2, 3, 6, 18, XZ. Okay, so this is almost, well, this is a detector in the radio. Why is it way over here? Okay, and the next tube, here we go. We're starting into the, oh, I'm going to do it in the other tube tester. Poor cat. The cat is going crazy. Come on, let's get this out of here again. I forgot. Okay, here we go in this tester. I say my cat is working hard on the bench too, doing the cat stuff. So I have this set up now for a 6H6. You know, this is a diode, so there isn't any mutual or transconductance as far as I know to measure. So perhaps for these kinds of tubes, diodes, maybe rectifiers too, this thing is just an emissions tester in the end. It has a single setting, whereas the emissions tester, the other tester, had 2. This has only one test. When did you get that? Uh-oh. Uh-oh. There you go. Oh, she's ready to play with anything. Short test, watching the meter on this one. No indications of a short. So for this tube, P1, P1K1, or P1K1, and we're doing a diode check. So it only has to get up this high on the meter. Here we go. Something a little wonky there. It's up above, and the other. Okay. 6H6. What was it supposed to come up to? I didn't really read it. 12 diodes. So it's good. Okay, this is a simple tube. It's very unlikely to be defective. Now we're moving on to the next tube. And the situation's a little odd here. So the next tube I pulled out is a 6J5. But the tube the radio is calling for in that position is a 6F5. Now perhaps they're interchangeable. I don't know. 6J. I have a number of tubes. I have enough tube substitutions books that I can substitute the book itself. Let's try this one. And we're talking about an old 6F5. 6F5. So this is an older set of tubes, like from the 30s, as opposed to the 40s or 50s. And tubes are a little more scarce. Well, a lot more scarce actually. 6F5 can be replaced with 6F5. You can't replace it. Oh, here's another one, 6F5G. 6F5. There's no replacement. These are all different versions of 6F5 here, and this shows no replacement except another 6F5. But what's in there is a 6J5. So let's look at the 6J5. The basing on here, 6F5, is 5M. 5M. And then a 6J5, oh, it's on the other page. 6J5, GHI. It's way the heck over here. 6J5. It can be replaced by, oh, it's a 6Q. It's a different base. I don't think these are similar at all. 6J5. So one here, one up here, but it's a 6L5, 6C5. Well, it's in here a lot. Why do you keep repeating it like this? 6L. 6L, 6C, no 6F. Try another one. 6F. Five. So this is already a kind of a serious problem here. 6F5. 6F5 can be replaced with 6F5, 6F5G, 6F5. It's the same as the other book. I'm not surprised. Wait a minute. Oh yeah, 6F6. No, it's all. As far as I can see here, just based on these books, you cannot just pop that tube in there. 6J5. Let's look a little closer here. It already says the basing is different. 6J5. Metal type 6J5, glass octal type, used as detectors, amplifiers, or oscillators in radio equipment. It's just a triode. It's nothing more than a triode. 6J5. So if we look at 6F5, E, A, B, C, E, F, 6E, 6F5. High mu triode, medium mu triode. High mu triode, it's just a triode. Metal type 6F5 and glass octal type 6F5 used in resistance coupled amplifier circuits. Outlines respectively. Outline of tube requires octal socket. And you come with pin 1 omitted. Resistance coupled amplifier. Well, so we look at the pin layout on the 6F5. Oh my gosh. Oh, something's been done here. The 6F5, notice it's only got 3 letters in its name. It's because it has a cap on it. 6F5 has a cap. The 6J5 has a 6J5, no cap. No grid cap. Okay, so it looks to me like someone has altered this radio so it can run a 6J5. That's the impression I get. And why do I say that? Let me just pop the camera off the tripod here and I'll show you. Because when I look down at the, oops, tangled up cord here. Hold tight. Flying around my shop here. When we look down, not at the cab, but when we look down the radio, let's look at here. Well, you see this tube with the grid cap, you see the wire heading for a small hole. It's a big hole there. Heading for a big hole here. A fairly big hole there. There's a big hole there where the tube goes. And I think the grid cap wire used to come up there. It's not there anymore. So either somebody foolishly cut it away and stuck the wrong tube in, which doesn't make any sense at all, or somebody's altered this radio so it can run with a 6J5 in the front. It's just another triode. Move some wires on the socket and you're done. And correct the grid thing. So I think we're going to look under the radio and find out what has happened here. Now the bench is all crowded with tube testers and cats and everything under the sun. Up we go. Ooh-ah. You just keep the audience occupied there, cat. All right. Get some wooden blocks in place here. Okay, there we go. Okay. The tube we're pondering is way up here. Way up here. The question is, has somebody gone in and altered this? It would be right in this socket here. I need a little more light on the topic. So I'd be looking for funny wiring things that have gone on here. Freshened solder, doesn't look the same as the rest of the radio. Still need a little more light. Let me just hold this here. Well, maybe there's signs that it's been altered. It's not terribly clear. I'm looking at it. This red wire here has a funny kink in it, just where it's reaching the. My light's falling apart here. Where it's reaching the, like a kink that was because it was somewhere else. The rest of these look really good. Maybe there's only one or two wires that have to move. This all looks original to me. This doesn't though. This, you know what? This is floating here. This isn't even hooked up to anything. It's just floating. I saw some other floaty connections. There's one over here. Floating right here. It's actually the other end of the same red wire. This just doesn't look right. It looks like somebody's done this. This red one. After the fact. To go further, I have to get the schematic out and study it and then compare it against the tube base. But I'm not at the schematic point yet, so nothing obvious there. But you know, unless it's been altered, I don't think the radio can operate. You can't just pop a tube in like that. And I just have my doubts that that's what's happened. Somebody has done some alteration work here. So we'll go ahead and we'll test the 6J5 as soon as I can find out what I did with it. Shadow, did you do something with the tube? What did you do with the tube? You've gone and here it is. Here it is. Look guilty? She looked guilty there, boy. There it is there. Yeah, I said something about not videoing all this, and here I am going ahead and doing it anyway. Let's pop these out. 6J5, it's right here. 6.3, 123, A46, A46, 15, WY is the test. Now this one does have a you can set the tube up and read a transconductance. Transconductance, I may not get this exactly right, is the ratio between the voltage variation on the grid and the current variation on the plate circuit. And that ratio is dependent upon how you operate the tube. So the tube testers, not this one, but my other one, will have a number suggesting what a good mutual conductance should be, or you can look in your tube manual and you'll find mutual conductance numbers. The thing is, that's under certain operating conditions for the tube to get that exact number. So you'll find the same tube in different tube testers appears to have different mutual conductance numbers. Okay. Enough of that. Here we go. And the test I had said was 6J5 WY. Here we go. WY. It's not testing good in this one. It's kind of on the line. 65%. Yeah, this is relative micromoles. Relative micromoles. And it's a percentage scale. So it'd be a relative, I don't know, 100% is in the middle of the good. The 100% must be the tester thinks it's encountering a tube which is factory quality, brand new. Relative micromoles. Well, this is a high quality emissions tester. Maybe I'm being unfair to it by calling it an emissions tester. If it's a well, it says dynamic tube tester, so I'm going to leave. I don't know what to say. It says dynamic tube tester. That's usually the suggestion that it's a transconductance tester. I don't know. Anyway, let's test this tube again one more time. Then I'm going to note the number. WY 70. It's right on the line. 70. Somehow I've lost my pen. Here it is. Here it is. 6J5. 70%. Right on the line. Okay, on to the other tester. Six J5. I have to improve the lighting here for myself, that's for sure. 6J E F 6J5. 6.3 signal level 2, 18H 273. What is that? 305 27305 27305 6J5 0610 28 F. Be very, very careful when looking at these charts that you don't accidentally start reading the line below. So 840 is the reject point for this tube. In she goes. A lot of tube testers, or some tube testers, do not apply any voltages, any high voltages to the tube until you perform the test. And saying high voltage doesn't even make it correct. So what that means is, other than the heater, nothing is being fed to the tube. You can twiddle these dials, except for the heater. This one's not apparent which ones are the heaters. I think these. I'm not even sure. If you have another tube tester, it's quite clear the first two numbers are the heater. As soon as you get these set, you can pop the tube in and then change these all you like. But other tube testers, if you change these while the tube is in, even if the test button isn't pushed, bad things can happen. Okay, so now we're going to try to measure the mutual conductance. Just making doubly sure I'm on the right thing. 840 is the rejection, so it's got to get above where my finger is here, just above the number 50 if you can see it. Can't quite see it. 50. There we go. So that's reading just above 900. So 840 would be the rejection point. 40 would be, well, just a little bit lower. Good, it's working. Tube works. So the test results for me in what I do here is basically the tube is really dead or totally dead, and I got to get rid of it. Or the tube is working to some degree, even if it shows poor, I'm not getting rid of it at that point. I would potentially retain it in my collection and put a stronger tube in. I would not throw away a tube that simply measures a little bit weak. Oh my gosh, Shadow. What do you say we stop for a few minutes here? Because this has become quite involved already. And it's just tube testing. What do you say to that? Yeah, let's go have a little break. Come on, Shadow, you can't stay in here. Come on. Come on, snap to it. Oh, she's... Come on. I don't know what's happening to that cat, but she's losing her mind here. She's affected by electromagnetic radiation on my bench. Her brain is scrambled. There's nothing to see there. You're looking at nothing. Come on. Oh, she's going to go to sleep. Okay, I'm going to leave her here. You mind the shop while I, literally, mind the shop while I go and rest up. There she is down there. My cat Shadow likes to park herself in the main traffic crossing points in our house. Top of the stairs, intersections, you know, and hallways. She likes that for some reason. Well, things have gotten a little bit stranger again. So this was supplied with the radio. This is a photocopy of a sheet from somewhere. I'm not exactly sure where this came from, but it came with the radio from the owner. So it's a 1029, and on the metal tag it says 1029. But when I look at this, and this is not going to go well here. Hang on a second. See if this will fix things up a little bit. So when I look at this sheet, okay, so that's the magic eye. That's the magic eye hanging here, and you can see the 6H6 I just did, the 6F5, which is a 6J5 in the radio. Now when you look down the back here, you can see an IF can with tubes on either side. There's the IF can with tubes on it. No, that's not a tube. You can see one tube, two tubes, capacitor, and three tubes. One, two tubes, capacitor, and three tubes. So either, you know, this diagram has been made more efficient by shrinking it a bit to pack it on the page, and this back apron has been basically not shown here, and everything kind of shoved forward on here. So you end up with this tube in line with this instead of the way it is. It's over here. Are these significant differences? Maybe not. Maybe not. 6J7. 6J7. Just noticing the duplicate tubes. And this rectifier tube, which I thought might be an 80, but the number isn't. I couldn't find the number on it. According to this, it's a 5T4. 5T4. Never heard of it. These are all bad signs. These are fairly rare tubes. I'm sure they're all gettable for a price, and I'll have some of these in my stock, but certainly not this. I have to hope that this guy works. Well, we're going to find out, aren't we, once I get there. So, next tube to test is this one. I'm going to end up removing the grid cap. It's going to cause this wire, this green wire, to flake some more. So be it. I'm going to be replacing the grid cap wires. That's on there. I shouldn't be twisting it like that. You twist these sometimes, not so much on these metal tubes, but on glass tubes. You twist the cap right off the glass tube, or loosen it. You just need a little wedging help there. And then you got a problem with the cap coming loose on the tube. So I can kind of see the outline of the window where the tube number should be. I don't see the tube number. It's wiped out. Yeah. Sometimes the number is stamped into the base. Something right there. Very weakly stamped. I've already found one tube not the same as what the schematic shows. This could be another one. I'll have to test this as if it is the correct tube. It probably is the correct tube. And then the tube test will tell me if this is the tube that it claims to be. Which would be, what is this one? This one would be supposedly a 6K6. Is that the only 6K6? 6K7. 6K7. Not a 6K6. 6K7. See any hint of that? No. Okay, well, we'll try it. There's two 6K7s in this radio. Here's another one here. This is a glass one. Okay, so we'll test this one first. See what we get. 6K7. 6K7. Right there. 6.3 A1236. A1236. 459. 15. Right there. WY for the test. Doesn't say cap. I don't know if this tester actually has a note. There's really no room to put notes in this little window here, so I think you just automatically put the cap on if it appears to need it. Just give it a minute. Okay, that's a minute. Watching the light. Now, a lot of times the instructions are to whack the tube while you're doing the short test, but I don't do that. Excuse me. WY. 6K7. Yeah. She ranks pretty good on this one. It's right on 100. 6KY metal. 6K7. 6KY. 100%. Okay, I'm going to do the same tube now in the other tester. 6K7. 6.3 to 33L. 17342 17342 0610 0610 43 over here. C. Grid cap peptode. Grid cap. Go. Okay, looking for shorts on the meter. Nope. This guy should come up to 1070. So just above 1,000 here. Right on. Good tube. tests good as a 6K7. We can bet it is a 6K7. I'm just going to pop that back in the radio. I'm going to pull the other one out of here, the glass one. There we go. Double check that it's a 6K7. Yeah, I can certainly see it there. Sylvania. So I'm hesitant to push the test button on this. This is a pretty old tube, and it may have developed some gas inside from components inside the tube. Not from a leak, but from components volatilizing a little bit. The gas in there can be ionized, and then if it's ionized, it can collect on the electrodes. It can collect on the cathode. Maybe even on the grid too, I'm not sure. So the solution, I've just been reading about this, the solution is to heat the tube up and leave it hot. It has to get very hot, so the glass gets hot, so the getter that's no doubt on the inside of the glass gets hot, and once the getter chemical gets hot, it will start getting the gas out of the tube. But you got to give this thing time to do this, and I don't know how much time is involved, or really how important it is. I've just been fiddling around with a line control here. Let's just double check here. So let's go ahead, because I've almost never done that anyway. And there's no way this tube is not even hot. It'll take an hour or so sitting in here. The idea is when you apply the voltage to the elements like the plate, as soon as you do that, the ions, which might be positive ions, will head in the opposite direction from the plate. They'll head for the cathode. And so these ions then contaminate the metal of the cathode and cause deterioration in the operation of the tube. She's a good one, isn't it? It's supposed to come up above 10, up above the 1,000 just a little bit. It's just below. So this is a little bit weak. In fact, this number is the reject point, so you really don't want the tube to be below the number, or it should be rejected. But this is a case where I wouldn't reject this. You can't go around rejecting things like this. You don't have new tubes in a box to sell somebody. So now this would have been a tube sell. I would have sold this tube, made some money. So this guy came out at about 900. And it's supposed to be 1070. Okay, I'm just writing this down here. Okay, we'll put them back in. So replacing this grid cap is challenging because it goes into the can. That means taking the can off and just going further and further when you really don't want to. So I may be able to replace this just from the top here. I may not even replace it. I mean, it could be a bare wire here. This one's the problem because it goes through the chassis. And next tube would be this one in the middle. What is it? Supposedly that's a 6L7, another tube, you know, I don't know, do I have one like that? 6L7? I don't know. I mentioned these when you, the tubes with a name that only has 3 digits, you know, 6K7, are older by a decade roughly than a decade or more than tubes that have 4. It's like 6SK7. 6L7, Radiotron, Westinghouse. This is where the money was. 6L7. 6L7. Okay, 6L7. There it is there. 6, where? Where'd it go? It was right there a second ago. There it is, 6L7. A1236. A1236. 4, 5, 9. 4, 5, and 9. 25 on the big wheel. WMY for the test. Got a grid cap. Must be getting some tube dust in my nose here. Okay, shorts. When the short light flashes, that's a hint that the tube is actually good. Okay. 6L7 WY. It's an 85% tube. 6L7 85%. And I guess the suggestion here is when you get to 70%, that's when it's time to think about a new tube. That's what this tube tester is subtly saying. Let me go back down to this one. 6L7. .32 signal level, 25 L for bias. 27345, 27345, 0610, 0610, 44. See, pretty similar to what I just had in there. So conceivably, if the tube tests similar to the other tester, 830, we're going to get it, it's going to come up somewhere around here. Okay, short test first. No shorts. Double checking everything. 830. Way over. So this is testing way up here. Instead of 830, it's up around 1300. So it tests really good. 1300. Let me just write that down. And the reject point was 830. So one tester 85%. The other one almost, well, not quite. I was going to say almost double the reject point. So can you compare those kind of? I don't know. Can you really relate those two together? Tube is good though. I don't think there's any doubt of that. Okay, this guy's next. So these caps, are made of steel, plated steel, and the idea is the steel is springy. They need the springiness to make it clip on. The problem is you can't solder to steel. So very often the wires, the wire that comes up here is crimped in here, and that's about it. Yeah, there's no solder, it's just crimped. Well, those crimped connections, you know, how long can they last? 6J7 is what I pulled out of the radio here. 6J7 on the diagram. Yeah. That's good. Okay. No conflict there. 6J7. Here we go. 6J7. 6J7. 6.3. A1236. A123 and 6. And 4, 5, 9. 4, 5, and 9. 25. WY for the test. Yeah, I'll put the tube in before I do the test. So this is a fairly new acquisition for me, this tube tester, and the other one I've been using for years. So I'm quite comfortable with the other one. This one, I'm actually quite comfortable with this one already too. But the reason I'm doing this in two tube testers is to kind of compare this one against my supposedly known good one. Here we go. Okay, see the flash. Actual test is WY. This is reading 80%, falling slowly. 80% in the good. J7. I think I have some of those. Okay. 6J7. .3 to 31 L. Wow, there's a 1 there, but at a glance, because there's a little scratch on my plastic here, the 1 looks like a 3 when I put it down here. Oh my gosh. 17342. 1342. Oh, 610 again, 0610 40 D. Great catch. Okay. $800. Right up above there. Well above. And the actual is 1100. Okay, write that down. 1100. And it only has to get to 800. So that's a good tube. I think in the sort of a go no go sense, just about any tube tester is going to do it, really. Why you need the precision, I'm not sure. Can't find my big screwdriver; it's disappeared. Anyway, probably Shadow took the big screwdriver when she left. Want to see if she's still out there? If you said no, I'm ignoring what you said. Oops. I just barely see her there. Move the camera. What are you doing? What are you doing? That was a mistake. Here she comes. Oh no. It's really not what I wanted to have happen. Okay. Next one we're going to do is the big 6L6 output tube. I hope this guy's working. What a beast. The reason I said that is I'm pretty sure I don't have a replacement. 6L6 are special tube. 6L. 6.3, 1, 2, 3, 4, 5, 6, 25. Test is W. 6L6. Okay. So a whole bunch of 6 tubes, 6L6, 6W6, 6V6, 6K6. The 6L6 is a little different. The other ones are all quite similar, and I think to some degree they can be swapped around. But not this one. I think it's significantly different. That's my thinking. Could be wrong. Can always be wrong. Lots of ways to be wrong. Oh, okay, that's good. No, that's good. Good, good. Flashing is good. 6L6, 6K6, listen to me. W. Okay, baby, come on. Oh, hot diggity dog. It's working. It's actually up at 90% and holding nicely. It's actually still going up. Still warming up. 90% on the 6L6. Okay. Now I'm going to just leave that in there cooking while I set up the other one. Try to maintain the heat here. 6L. Same as an EL37. 4. 35H. 07345. 07345. 0610 again. 0610. 44. I just realized my door is open and the TV can be heard. Don't want that. Shadow's back in her sitting spot again. F. Still missed that. We need a double check on this tube. 07345. 0610. 44 F 1300. So this should come up somewhere up like this. Okay, let's get it out of this tester. Sort of keeping it warm. Okay, should be ready to go for this test. She's a pass. 6L6 1300. Right up here. Oh my gosh, look at that. Holy smokes. She's a beauty. Oh my gosh. This is one great 6L6. Probably got hundreds and hundreds of hours of operation left in it. Particularly if the radio's in good shape. One of the things you can do to these output tubes is you can, if the bias isn't correct, they can have very heavy current flowing through them. You wouldn't know it while you're listening to the radio. Meanwhile, the thing is hotter than it needs to be and wearing out faster. Now we're into another really critical tube here. According to the thing, it was a 5T4. 5T4, is that the same as something? 5T4. Let's try this book quickly just to see what it might say. 5, before I blow it up in the tube tester. 5T4. Replaced by a 5AR4. I think I've got a bunch of those. I think I've got those. 5AR4 or a 5R4G. Must be a stronger tube because the 5R4 is right here, but you can't put a 5T8 in. So 5T8? 5T4. 5T4. Okay. Yeah, that's okay. Now, I think my cat has changed color out there. It's no longer a black cat. I have the feeling... Who's out there? Aha! Okay, both of you guys want to go out? Is that what's up? Okay, hang on. Just have to stop for a minute and let my cats go outside in the beautiful weather. Because, you know, once they gang up on me, I can't resist. Okay, we're all set for this really big guy. Oh, why is he so big? Because he gets so hot. That's why. To dissipate heat. And see the size of the plates? A lot of current going through. This is the power supply rectifier. So you need big plates to handle the heavy current, or there'll be too high a current density in the plates and they'll get too hot. So that's why big tubes are hot tubes. Big tubes wear out sooner. I got this guy set, but let's just double check because I don't want to blow this. So 5 volts. Yeah, 5 volts on the heater. 1.3 with 5 here. 15 on the big wheel. That's it. In you go. Okay, I hope this guy's good. And the output tube and the rectifier tube are the two tubes that work really hard. I see it heating up, both sides. Okay, short test. Shorts are common in these tubes, not this particular type of tube, but I mean rectifier tubes. No shorts. This is the moment of truth here. We push W and find out what's happening. This is one side, one half of it. Ooh, she's good. The other half we get to by switching the 5 to an 8. Other half, W. Thumbs up on that. So I don't think this tube really needs to be tested in the other tester. Just don't see the value in it right now. It's just too much of a risk to do anything more with this tube than put it back in the radio for now. So I'm pretty sure I can't replace it out of my own stock. That leaves one last tube, and that's the Magic Eye tube to check. So far we found all the tubes working. One may not be the correct tube. Still need to know if the radio's been altered. It gets up here. Oh, up there, way up there. So testing a Magic Eye tube is a bit of an oddball in testers. They're all a little different. Let's see what this guy says here. So this is a 6E5. Okay, 6E5. There it is. 6E5 visual test. 6.3. 1, 2, 3. A45, A45, 20. So I guess on this we use the good bad check, and then the other setting that's in there is to trigger the which socket am I going in here? 1, 2, 3, 4, 5, 7, 1, 2, 3, 4. Going in there. Now again, I don't think the tube lights up with this particular test. It's not even, yeah, it's heating up. It's heating up. Okay, so most of the time these tubes are worn out in old radios. And you should never have too much hope when you're doing this. Checking now for shorts. Good. WX. Watching the meter. WX. Ah, that's a good sign. Okay, now the next thing is this visual test. Change the bottom row to A, B, 4, 5, 6. A, B, 4, 5, and 6. Set this to 0. WX again, and this should make the bulb glow. WX. Oh, not bad. Not bad. Not bad. Again, I don't think there's any reason to test this tube again, because this also is a tube. You don't want to wear it out. You don't want to mess it up. These are a little expensive these days to buy. And if you've got one that's good, hot diggity dog. I'm going to put it back in its holder here. There. Probably at some point in repairing this radio, I'm going to have to take apart this arrangement here and go after a resistor. Or did I find on the last radio it was underneath? I can't remember now. Can't remember. Okay, did we do every tube? Did I put this cap back on? No, I didn't. Good, we did every tube. All tubes are functioning. One tube is questionable in terms of what's it doing in the radio. That's this one. We have to do a little checking to see about the wiring of the socket here, and that's what's going to be required. Have to get the schematic. Good, but we're definitely on our way here with a really cool radio. So thanks a lot for watching, and tomorrow I will carry on. We'll figure out what's going on with that tube and the socket, this one here, and think about starting the radio up. Maybe. We'll see. I'm going out to enjoy the summer-like weather here. See ya.